Okay, what have we found that we need to go over? Remember, I could be wrong, so it is just something we don't match on that we need to talk about. Drew?
14.
14? 14? All right, so we have to change one side into the other side. Okay? So I got to work over here because I can see some stuff to do. So if I'm going to change all that into that, clearly I got to get rid of these cosines because there aren't any cosines over there. And what do I know about cosine squared? Things to know. Things to know. What do I know? Sine squared plus cosine squared is 1. So what is cosine squared? 1 minus sine squared. So I'll just take out the cosine squared and replace it with 1 minus sine squared. On the top and the bottom, get rid of it all. All right, so now I got some arithmetic up here. More arithmetic, collecting like terms. Now, guys, honestly, if this is what you have and that's what you want, don't you have to get rid of some of this? You gotta get rid of some of this. And how do we get rid of things? We cancel. So let's see if we can factor. Now, I had somebody in here this morning having a really hard time factoring this because of that negative out there. So it's okay, get rid of it. But if you get rid of the negative on the top, you also have to get rid of the negative on the bottom. It's like multiplying top and bottom by -1. Is that legit? Yeah, but you have to do it to top and bottom. Now, does the top factor? Does that work out? I think so. And then the bottom factors, because it's the difference of squares. And lo and behold, and what's left? Exactly what we wanted, right? Yep. So every one of those problems is going to be different. They're just all different. But think about some of the things that we thought about as we were doing that problem. First of all, if this is where I'm ending, it's all sines. So maybe get rid of the cosines, which we can do easily. We have a mechanism for that. Then this is way bigger than what I wanted, so I knew at some point I had to cancel. And how do I cancel in math? First side factor. Okay. All right. Who else found something that we need to do? Xander?
Could you go through 8, please?
8. Find the average rate of change. Okay, so remember, your average rate of change is going to be all over the interval 0 to 7 pi over 6 is going to be r of 7 pi over 6 minus r of 0 over 7 pi over 6 minus 0. And we're going to write that down. All right, we're going to write that down. It's probably going to be part of a free response question, so we're going to write down, this is how I'm calculating average rate of change. Okay, everybody remember that? Okay. Joe, you better be doing math over there.
I'm looking at the answer.
Okay. Now, I have to figure out what these things are. I know my denominator is just gonna be 7 pi over 6. But I need to find out what r of 7 pi over 6 is. So over here to the side, because it's too much to do in my head, I'm gonna have 5 cosine. All right, what's 2 times 7 pi over 6?
14 powers.
Well, 7 pi over 3, right?
Theoretically speaking.
And then minus the sine of 7 pi over 6 squared. Okay, what's the oh wait, 7 pi over 3 is too big?
Pi over 3.
So I'm gonna get rid of
2 pi.
2 pi, and that's just gonna be the same as
Pi over
pi
3.
over 3. So what's the cosine of pi over 3? So this is 5 times a half, or 5 halves. What's the sine of 7 pi over 6? Negative
Negative
1 half, but it's squared, so that's just gonna be minus 1/4. So I'll get a common denominator, and it looks like that's gonna be 9/4. So this right here is 9/4. Now I'm gonna find r of 0. So what's the cosine of 0?
1.
Times 5, that's gonna be 5. What's the sine of 0? So that's just minus 5. So the common denominator here, that's going to be negative 11 fourths, did I subtract right? Times 6 over 7 pi. I got negative 33 over 14 pi. All right, what else have we found?
Can you do 12?
So we got an inequality that's a greater than, I gotta pay attention to that, but greater than. All right, so hopefully this guy factors. Does he factor?
Yeah, I'll do that.
All right, so let's do that. So we got 2 cosine, cosine, minus, minus, 1, 1. Is that how it factors? Okay. Now, cosine equals a half, cosine equals 1. Those are kind of the key values for it. And it's an inequality. I'm multiplying these two things, and it has to be positive. So that means either both of these are positive, or both of them are negative. So in terms of, if I draw a regular rectangular graph, here's my cosine. Here's pi over 2 pi, 3 pi over 2, 2 pi. Here's 1 half. I'll do that one in red. Here's 1 half. So those points would be right here and right here. What are those points? Where is the cosine 1 half? Pi over 3 and 5 pi over 3. And then we have cosine equal to 1. Well, actually, that one's not included. So here's that line, right, where the cosine is 1. So if I want to be positive, positive, that means I want to be above both lines. So above red, above pink. Right? Well, the only part of the curve that's above both is that dot right there. Would you agree with that? So the answer to the plus plus is just x equals 0. Now, minus minus means I need to be below both lines. So that looks like it is this part of the graph right here. Right? Which is everything in between pi over 3 and 5 pi over 3. So my answer is those two things put together. Does that make sense to you? All right, what else? Did you have a question about on here? Yes.
Can you do 9?
9. Okay, it's a calculator problem. And the reason it's a calculator problem isn't because it's anything fancy, but these numbers are not numbers from my unit circle, right? So this says the sine is 3/41. Now, I'm gonna change it to a sine all the time just because that's how I do it best for me. You don't have to. But certainly in a calculator problem, it makes sense because you're gonna be typing that in and you don't have a cosecant button. All right, where does the sine equal a positive number? Let's start with that. Here or here, that's where the sine is positive. Okay, so how am I gonna find that angle on my calculator? Make sure I'm in radians, and I'm gonna type what? Second sine 3 divided by 41, and I got 0.073. Now, the answers to the question are this angle right here, which is 0.073, and then this one, which would be pi minus that, so 3.068. Is that what I have on the answer sheet or not? Okay. Okay, Olivia, does that make sense to you?
Yeah.
Okay.
Can we do like 16, please?
16. Okay, this is the one where I have the picture upside down. So, I warned you about that. So sorry that happened. But yes, the picture is upside down. So I'm gonna write down what I'm doing and then I'm gonna turn my paper over. So the function is 6 cosine 2 theta. And I'm going pi over 2 pi. And I want to know basically what parts of the graph that describes. So I'm going to turn my paper over so I'm looking at my picture the right way. And I'm going to plug in pi over 2 for theta, because that's what it tells me to do. So if I plug in pi over 2 for theta, it looks like I get, what? What's the cosine of pi? So I get -6. So that point is going to be plotted at 6 comma 3 pi over 2. Would you agree with that? So I'm looking at my picture. At 6 comma 3 pi over 2, it looks like I have point D. Right, everyone? Okay, so in the problem, they actually told me that one piece is going from D to E. So I'm starting here at that D and I'm wrapping around to E. All right, well, let's try the next point. What happens if I put in pi? If I put in pi, I don't get 0. I get 6. Okay, so where does that point get plotted? 6 comma pi, isn't that over here? So what part of the graph am I looking at? From whatever this label is to this label, this point to this point, whatever that is.
Okay.
That makes sense to you?
Yeah.
It's
So-
easier when it's right side up, sorry about that.
So would it be e to x?
It would be, E is the center, right? Yes, it would be E to A. Yep. Quadrant 2, E to A, answer ratio. All right, anything else? From the sheet. Jacob?
17.
17. This one I think was okay. All right, so my equation is 4 cosine phi theta. And this time I am going from pi to 3 pi over 2. All right, so let's just plug in these points. So if theta is pi, what does my r turn out to be? Turns out to be 4. So if I'm looking at my graph, pi 4 would be over here. Okay. Now, they didn't give me any interval here. So, but I bet I can do it without that. Plug in 3 pi over 4. What do you get when you plug in 3 pi over 4? Or 3 pi over 2. I'm sorry. 3 pi over 2. What do I get when I plug that in? I get 3 pi, so I get negative 4.
Yes.
So where is that point getting plotted? At 4 comma pi over 2, which is up here. So this is a multiple choice question. It looks like the only option is A, that connects those 2 points. Now, if you were worried about like what the connection looks like, you know, in this case, elimination, got rid of everything except A, but you could put in a point in between. So you could literally put in, what would be in between 5 pi over 4? And you could plot that point, and that would show you this is connected to this, and then this is connected to this. Okay, so how do we figure that out? We simply plotted points, right? All right, what else?
Can you do 11A and 11D?
11A. And D has a typo in it. D should be the inverse sign, negative 1/2. So that's the way I'm gonna do it. That's what it should have been. I tried to correct that one. All right, the sign of 11 pi over 6. What's the sign of 11 pi over 6? Negative 1/2. Is that where you made your mistake?
I don't know.
Okay, well, we gotta know our unit circle. This is a pi over 6. The sign at pi over 6 is 1/2. This one's negative because it's in quadrant 4. All right, what's the tangent of 5 pi over 4? The tangent of 5 pi over 4 is 1. So we're minusing 1. I'm getting negative 3/2. I hope that's what I got when I did it before. All right, and then D should have been this. This is the way that should have been written. So sorry about messing you up. That's how that should have been written. What is the angle whose sine is negative 1/2? Now, remember, guys, it is not 11 pi over 6. I know the sine of 11 pi over 6 is negative 1/2, but this is not negative, or this is not 11 pi over 6. Remember, when you're doing inverse You have to be looking over here. Here is the angle. What is that angle? Negative pi over 6. So this is negative pi over 6. Now, the angle whose cosine is negative a half, cosine is here. So that angle is over here. What angle is that? 2 pi over 3? So we should be just subtracting these two numbers. So, oh wait, I'll do that. I'm hoping I said negative 5 pi over 6 as the answer. Okay, what else? So all of your questions on the paper, anything you missed has been answered. Mike?
Letter F on
11F says find the cosine of 11 pi over 12. Now, is 11 pi over 12 one of my unit circle angles? No. So if I am being asked to find its cosine without a calculator, I'm going to have to do what?
Split it.
Split it into angles that are on my unit circle, right? And they either add or subtract to give me 11 pi over 12. So my angles again are pi over 6, pi over 4, pi over 3. And if I turn those into 12ths, just for my own messing around, how could I get 11 out of that? Might have to go bigger. Might have to go bigger. So maybe, what would be next after that? 2 pi over 3? That would be 8/12. That'll work. What if I add this one and this one together? Will that give me 11? And that's one option. You could find other options that would also work. But I'm gonna have the cosine of pi over 4 plus 2 pi over 3. Because those two numbers added together make 11/12. All right, stuff to know. What's the formula or the identity for cosine angle plus angle? Cosine first, cosine second, minus sine first, sine second. Perfect. All right, now I'm just gonna start plugging these in. Okay, now you need to be careful because some of them are going to be negative values. All right, cosine pi over 4. 2 over 2. Sine is the same. All right, now 2 pi over 3. Negative 1/2. And sine will be positive root 3 over 2. So negative root 2 minus root 6 all over 4. Okay? All right, any other questions not answered? All the questions are answered? All right, here's what we're gonna do then. I'm just gonna throw a couple up here and somebody's gonna come up and do them, all right? So I need a volunteer to come on up. Who's gonna be my volunteer? It's a birthday, don't make her do it. Unless she just really, really wants to.
Step up to the plate. Step up to the plate.
Not everybody.
Good Brady.
Oh, let's go.
Nice. Yeah. Yeah.
Yeah, that
Here we go, alright, so here's your problem.
Only guy that packed.
Sine x over 1 plus cosine x plus 1 plus cosine x over sine x equals 2 cosecant x. Alright, now, all of you should have a piece of paper out of the back of your homework or something, and you should be working on this right along with Daniel. And we might give him some coaching if he gets stuck. He probably won't.
Yeah, Daniel, I don't know about
I got this right, genius.
You done already?
I think so.
Awesome.
then you can make it cosine.
But I could have just bought it.
Yeah.
So you need to multiply that in the top two. Sorry, you're fine.
He is a nerd now.
it. You miss every shot you don't take. Keep going.
He don't like it.
Oh no, I like it. I like it a lot.
No.
I think he's on the right track. So I don't know if he paid attention or not, but I think he's trying to get a common denominator. Yeah?
Wait, why are you squaring it?
Oh.
I did.
Tammy, you did that?
Yeah.
Or that Jackson one?
Yeah. Daniel, little hint. You are trying to end up with something that's way smaller than what you started with, right?
That's why I was.
So let's not multiply out the bottom, let's leave it factored. Because we hope we can cancel something out, right? That's our goal. Now, look at your numerator, something's really good's happening over there.
That's easy. Switch to 3 times.
What do we see in the numerator, everyone? Sine squared plus cosine squared. So that's a 1. It adds to that 1. So now you have 2 plus 2 cosine. Which he's factoring, and then what magically, mystically is gonna happen? Very nicely done. Yes. All right, so the rest of you take a look at that. And let's talk about, every one of these problems is different. We talked about that already. So when you looked at the problem, Daniel's first impulse was get a common denominator. You are adding two fractions. How do we add fractions? We get a common denominator. Now he was ready to erase it because he noticed the problem was getting bigger and he needed to be getting smaller. But sometimes we have to make it bigger so that we can factor and cancel. And that's what he did. Okay, so this is one problem on the quiz. We're gonna do our very best, but we gotta make sure we know everything else, right? Okay, all right, I need another volunteer. Thank you, Daniel.
So 1 plus.
You're amazing. Wait, before we erase that, did you have a question, Xander?
No, I'm just.
Okay.
It's gonna be form of this question, right? It's not like gonna be the same thing.
Huh?
It's not gonna be the same exact question, right?
Oh, no. What would be the point of that?
I don't know, memory.
Okay?
I don't hate that question. I really.
All right, so who's gonna volunteer next?
Every
Let's have
last-
someone volunteer next. Who shall it be? Okay, if I call on somebody, it's not volunteering, but that's what I'll do if I have to.
Leave it in, let's go.
Thank you, Xander. Okay, so Xander, I need you to run this board.
Oh, gotcha.
And then you are going to find an average rate of change.
Can I erase this or?
Yep. You're gonna find an average rate of change.
Okay, I like that.
The function is r of theta equals sine theta plus cosine squared theta plus cosine squared theta. And the interval that you're finding the average rate of change over is pi over 6 to 5 pi over 6. Okay, so please set up your formula first.
All right. Here we go.
No, you're fine.
Patrick, did you do this sign?
Huh?
Did you do this? You work it out?
I mean, yeah, I'm like going to Kennedy goes. Shoot, wait.
0?
What do you guys think?
Oh, yeah.
Zero, absolutely, yep, that happens. Perfect, absolutely perfect, thank you, Xander.
Yep.
All right, who else? I need another volunteer now to come up and do another problem. So you calling on?
Calling out.
I know.
Did someone volunteer?
It's more fun when they volunteer.
Yeah, because they're both.
All right, Emily, to the board, Emily P. To the board. We're gonna, you can take somebody with you if you want.
5 fourths. I need to check this.
You can take someone
So
with
it's
you.
like 5 fourths minus 5 fourths. Okay.
All right,
Said, well,
go first, Marcel. All right, so erase all that.
Oh, you're not taking me, you're not helping me.
You're running the tape.
You can
Not this, I just.
Y equals -3 cotangent x over 3. Tell me where the asymptotes are. X over 3. Tell me where the asymptotes are.
Oh, is it?
I understand. What's it called? So here you this would be pop. Would you just said butter that? She has acid.
Where are the asymptotes?
I know that. That's what I meant when B is 1/3, like the period.
Yeah.
I think that's awesome. They figured out that they're, well, first of all, where are the normal asymptotes for cotangent? 0 to pi, right? So this time we put a 1/3 in front of that x, so it multiplied everything by 3. So now we're at 0 and 3 pi, and then another 3 pi, and another 3 pi. Beautiful. All right, next, here we go. Who we got? Come on, I want to get 2 more problems in. Okay, Patrick and Oscar, head on up there together.
Yeah.
Be a team.
Oh, it was.
Yeah.
Here we go.
You'd be like crying.
You guys are going to simplify. Here we go. We're gonna simplify sine parentheses x minus pi over 2.
Yeah, make sure there's an
X pi over 2. Yep.
Alright. Oh, wait,
Would it change if you did? Would it change if you did cosine like a first? Does it change the sign?
So now we're just gonna rinse this out.
All right, you got it. You guys done? Yep, you're right. You're right. That's it. That's it. Good job, boys. Nice work. All right, you guys go up, you're gonna solve an equation.
Maybe kind of sound.
Yeah,
I bet everyone thought we couldn't do it.
I need you to do it faster. I wasn't sure about that, but I need you to do it. All right. Yeah, scoot over a little bit more. Now, here's your equation. Cosine squared x plus 2 cosine x plus 2 equals cosine 2x. And you're solving from 0 to 2 pi.
Those two
It's a double like
Need to know
Is that the right identity to use?
cosine 2x. No, help them out. What's cosine 2x? 2 cosine squared minus 1.
Okay.
Oh, yeah. Yes, I'll change that too.
So that's step 1. Does everybody understand that? You gotta get rid of the 2x. Okay? Yes. Now we gotta get it equal to 0. One side or the other, get it all moved. We gotta be equal to
This is just
0.
like, yeah, this one is solving an equation. You're solving for
You can divide by a negative because this is an equation, right?
Yeah.
This is not anything funky, this is a regular equation.
Wait, if it was, what sine do you like translate to?
She's that cosine. Where's your need to know sheet, dude?
That's what I thought it was,
Yeah.
I just forgot that that one was different. This one, so we gotta subtract those out. So it'd be, we did cos squared
Okay, so now you need to solve it.
plus 2 cos minus plus 1. So we factor
So they did all that work and got one answer. What do you think about that? I think they're right. Can the cosine equal 3? No. So that's extraneous. They didn't make any mistakes. It just doesn't work. Can't do it. Where does the cosine equal -1? Only at y. Okay? So there's a few more extra practice problems for you. So tomorrow, you will take your quiz, right? No, Wednesday you'll take your quiz, and then I will give you your first practice exam, and we will start doing that.
So when I know it's like a number bigger than 1, so it can't be that.
Not cosine, sine, no. If it were secant, yes, but not cosine, sine. Yes, we'll be having a review quiz. Yeah, but life isn't over, folks. We're having review quizzes, we'll have review homeworks. You're gonna have stuff to do. But we gotta get this stuff behind us first. Yes, you are going to do Wednesday. And you're going to do Wednesday.
Wait, at this bed or place, it's only review stuff.
That you know, sheet will
That's
be
cool.
useful to help study this quiz too, right?
Well,
All those
yeah,
identities are on
yeah.
there.
So that's important.
That's all school.
Yeah.
And I gave you hard copy.
I'm gonna know the ins and outs.
All the.
And a lot of the need to know you already know. Like some of them you probably need to practice.
the one that would be for.
I know, like,